Think your eyes never lie? These illusions will prove otherwise. We're counting down 10 viral optical illusions and explaining the science in plain English. I'll show the trick, give you a beat to decide, then reveal why it works. By the end, you'll know the simple rules your brain uses to build reality. Your brain constantly guesses the world from limited clues. That's brilliant for survival, but imperfect for perfect vision. Context, lighting, perspective, and expectation can all bend what you see. Watch closely, make your call, then compare it to the proof. Illusion 10. Do you see a vase or two faces looking at each other? Lock your first answer. This classic flips because your brain must choose what counts as figure and what counts as background. When attention claims the central region, you get a vase. When attention claims the side profiles, you get two faces. The lines never change. Your interpretation does. Once you feel the switch, you can toggle it at will. Illusion 9. Two lines, same length, different arrowheads. Which looks longer? The line with outward fins appears longer, and the one with inward fins appears shorter, even though they match. Arrow cues bias how you read the endpoints, so your brain overestimates or underestimates the span. Measure them and the equality is obvious, but perception still resists the truth. That's your visual system prioritizing fast judgments over exact geometry. Illusion 8. A central circle surrounded by large disks and the same central circle surrounded by small disks. Which central circle looks bigger? They are identical. Surrounding context scales your size judgment. Big neighbors shrink the target. Small neighbors enlarge it. Your brain compares, not measures, because comparisons are quicker in the real world. Once you overlay outlines, the match clicks instantly. Illusion 7. Two tabletops that look like different shapes. One long and skinny, one short and wide. They're actually the same shape, just rotated. Perspective cues from the drawn legs and implied depth warp your sense of proportion. Rotate one tabletop and it fits perfectly over the other. This is a reminder that 3D assumptions routinely override flat image facts. Illusion 6. A brick-like pattern where straight rows look tilted. Those rows are perfectly parallel. Alternating mortar lines and high-contrast tiles nudge edge detectors in your visual cortex. The small misalignments accumulate into a global slant that isn't there. Add guidelines and the tilt vanishes, proving the rows never bent. Halfway there. Can you guess the top 3 before we reveal them? Drop your predictions in the comments now. Illusion 5. A checkerboard with a cylinder casting a shadow. One square in shadow looks dark, another in the light looks bright. Picked with a color sampler, they have the same luminance. Your brain compensates for lighting to keep surfaces stable across conditions. Shadow tells your visual system, boost this region, so it lightens the shaded square to match the scene. Slide a gray strip between the squares and their equality becomes undeniable. It feels wrong because your brain is usually right about shadows in real life. Illusion 4. The silhouette dancer that seems to spin clockwise for some and counterclockwise for others. Which way do you see it turn? Because the figure lacks depth cues, your brain can assign the rotation either way. Focus on the feet shadow or blink, and many people feel the direction flip. It's a bistable perception. Two plausible 3D interpretations swapping on a single 2D animation. Neither is wrong. The data simply allow both. Illusion 3. A concave face mask that appears to bulge out and follow you as it moves. You likely see a normal convex face, even when you know the mask is hollow. Your brain has a powerful prior. Human faces are convex. That expectation overwhelms shading cues that should reveal the concavity. As the mask rotates, those assumptions make the features seem to track your viewpoint. It's creepy, but perfectly logical once you know the bias. Illusion 2 is audio.
Laurel.
Some people hear the word Laurel, and others hear Yanny.
Laurel.
Listen once at a
Laurel.
neutral level.
Laurel. 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 Laurel.
Now imagine boosting the treble in your device or focusing on higher frequencies. Many will flip to Yanny.
Laurel,
Drop the highs or lean into bass and Laurel becomes clearer.
Laurel, 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 Laurel.
Your brain emphasizes different bands based on playback, hearing, and attention. Same signal, different filters, different perception. Illusion 1. The dress. Do you see blue and black or white and gold? Your brain guesses the lighting first because lighting changes everything about color. If it assumes cool daylight shadow, it subtracts blue, leaving the fabric looking white and gold. If it assumes warm indoor light, it subtracts yellow, leaving blue and black. It's the same photo, the same pixels, interpreted under different imagined illuminations. White balance in your head, not on the camera, drives the split. Illusions expose the shortcuts behind perception. Context anchors size. Edges steer tilt and direction. Shadows recalibrate brightness. Expectations fill in depth and even color. Now you can spot the trick and explain the why. Which illusion fooled you the most today? Drop your favorite in the comments and tell us why it worked on you. Share this to challenge a friend and see if they pick the same answers. Subscribe for weekly brain benders with clear explanations and on-screen proofs you can pause and test yourself.